Yeah, so my name's Sam Stokes, and I'd like to talk about observable systems and why you should stop reading your logs. Oh, that's the wrong way in my slides. So you might have heard some talk about observability. It's become a bit of a buzzword in the last year or so. It's probably buzzing around the conference a lot. And there's a lot of discussion of what is observability. You'll see a lot of blog posts discussing, is observability the same as monitoring? Or is observability a kind of tool? There's quite a lot of vendors that say they sell observability tools. The company I work for, Honeycomb, is one of them. But whatever it is, it's definitely something to do with DevOps. Oh, sorry, I said DevOps. I guess I have to put something in the swear jar. But I actually find this concept of observability, even though I work for an observability company, kind of abstract. Like, how much observability do I have? I find that hard to talk about. So I prefer to talk about observable. What does it mean for a system to be observable? And if you ask Wikipedia, it'll tell you something like this. The internal state of an observable system can be inferred from knowledge of its external outputs. Great. That's sort of dry, though. What I really think of observable meaning is, can you see what it's doing? And if it starts squeaking, can you see why? So I'd like to talk about why building observable systems matters, why we should try and do it. Share some tips and tricks for how to make our systems more observable and how to think about observable systems. And finally, I'd like to talk a little bit at the end about the relationship between observability and controllability and some things we can do to change our practices there. And so what to expect from this talk? I'm going to be talking sort of philosophically about what's good about observability, I think. I'm going to share some war stories. I'm not going to go super deep into like which tools you should be using or which libraries and frameworks you can use to get like this particular form of log output in your apps or anything like that. I'm going to try very hard to share some general techniques that you can use regardless of which tool stack you choose to be using. That's partly because I'm working for a tool vendor and I don't want this to come off as an advertisement, but I really think these are fundamental techniques that are worth all of us trying to do more of. And finally, I want to try and tie together some concepts that you probably know of, but you might not have thought as being related to each other in this context. Without further ado, why should we build observable systems? Well, I'd like to use, all right, yeah, why do we need to do this? We already build software to solve business problems. So our code has to work, has to solve the problem that we wanted to solve. And then there's all these other ilities, non-functional requirements that we already are being asked to observe. Our code has to be reliable, needs to be fast, the interfaces we build need to be usable, it's got to be readable so the rest of our team can understand it, it's got to be maintainable so the rest of our team can make changes to it later. And if we're really going out there, maybe it needs to be operable as well. Like, we need to build a system that we can run in production. So why add observable to this laundry list of non-functional requirements that we're already thinking about? Well, to answer that, I'd like to use an analogy. I'm not a car guy. I have a car, I know how to drive it. I could just about tell you how many cylinders the engine has, but I don't really understand how it works. I read a blog post once about how internal combustion engines used to work, but engines these days are way more complicated than that, and I don't really understand it. So, and yet, even though I don't understand how to drive the car, or I don't understand how the car works, I can still drive it. But my car is observable. My car has a dashboard that shows me something about what the car is doing and how it's working while I'm in the process of driving it. And one of the things that's useful about that is it shows me what normal behavior of the car looks like. I'm not going to immediately understand it, but over time, as I'm driving the car and passively consuming the dashboard, I'm going to learn things like well, okay, this is a reasonable speed. Hopefully I have other guidelines for what's a reasonable speed. But okay, my RPM is about 1 to 2,000. I guess that's normal. I got to 5,000 RPM and the engine started making a really weird noise. I guess that's not normal. I have a temperature gauge. It's like in the middle somewhere. That's probably good, right? I have a fuel gauge. So as well as helping me learn what normal looks like, I learn what normal doesn't look like. The dashboard doesn't tell me literally everything that's happening inside the car. I don't have a temperature gauge for every cylinder of the engine, but it tells me when I need to look deeper. I know, for example, that if my temperature gauge is not somewhere in the middle, that I might have trouble starting the car. I know that if my fuel gauge is going close to empty, then I should probably do something about that. The other interesting thing about this dashboard is it helps me understand the car in more detail than I actually need. It's not just about what the car is for, right? I can drive the car without ever looking at the dashboard. I can turn on the engine and stick my foot on the accelerator and drive around, and I could complete a whole journey without ever looking at my car's dashboard. And you all probably know somebody who does drive like that. But having a dashboard there means I can learn to be a better driver if I choose to pay attention to it. So bringing this back to software, because I assume most of us are spending more time building software than building automobiles, observable systems show us what they are doing while they're running. And that means we can learn what normal looks like for those systems while they're running, and tell us when things are out of normal and we need to look deeper. So they help us understand them so that we can be better at operating them. So we get to tie together two of these abilities already. By building systems that are more observable, I claim we can also make them more operable. But there's another nice benefit of understanding our systems better, because if we're building systems as software developers, well, understanding them is a pretty useful component to maintaining them and extending them as well. If we understand really deeply how a system behaves, that's going to make it easier to understand what kinds of changes we can safely make. Because fundamentally, you don't understand software until it's in production, until you've seen how it behaves. It's all too easy to just write some code and say, okay, well, it works, and it passes the unit tests, so we'll ship it, and we understand it now. We're all good developers. You know, we spent a lot of time code reviewing this, so we must understand it. And then you ship it to production, and the first wave of users hits it, and it falls over because there's a performance bottleneck that you didn't think of. Or there's an edge case because some script kiddie is trying to execute like PHP code against, you're not running PHP, but they're trying it anyway. And it turns out that your error handling code had a bug, and so your system is falling over. Like, there are things that you're just not going to see until production data hits you. What does normal look like? When the system's actually running, do you know what it looks like? What sort of signals is it sending that show you whether it's healthy or not? I have this diagram up there because I think a lot of people think they understand how the system works in production because they have an architecture diagram. You know, we have some clients, and then we have the internet, and then it talks to the server, and that's the architecture. Well, I mean, maybe you have more detail than this. Maybe you have, like, behind the server, you have a database, or you have a few servers and a load balancer, and you have the microservice that you're calling over there. But that's not really how the system is working in production. That's sort of the ideal state. But what happens if one of those things is down? What does the system do when it fails? Not just how can it fail, but what does it do? Does it crash? Do users stop getting answers at all? Does it slow down but continue to work? Does it start returning incorrect data? What does it do when part of it fails? We're all in a world now where we can have systems that are mostly still working, but part of them is down. If the cache goes down, does your system stop working, or does it just start returning different results to different people? So having observable systems means we can observe these things. There's basically no way to predict all of this up front, just having written the code. But if you can watch it and tweak it and poke it, then you can learn these things. So a good start is just graph everything. Well, actually don't graph everything. Graph 3 things. Latency, how slow is the system responding? Traffic, how busy is it? And errors, how often is it breaking? You'll sometimes see these referred to as the golden signals in the Google SRE book. And this is great. Like, if you're not doing this, then it's a really good idea to start doing this for all of your components and for an overall system-wide view. But if this is all you have, to me this feels like if the only thing you had in your car dashboard was a temperature gauge. The only thing. You don't know how fast you're going, you don't know if you have any fuel left. All you know is this thing that like normally is about in the middle. I mean, it's still useful to know, but you need more. What about the actual work that your system is doing? Is it still doing that work correctly? The things that are unique to your system that aren't the same for every single web app? What about your users? Do you know what experience they're getting? Let's say you've got a 1% error rate. Does that mean everyone's seeing 1% of their errors, 1% of their requests fail? Or does it mean that there's one really unhappy user who's seeing a completely broken site? You need to know that. A quick note, if you're looking at this and you're thinking, okay, but I'm the application developer. I have an ops team. That's their responsibility to run the application. If you're thinking that, then you probably want to try being better friends with your ops team. Because I promise you, they want this. If you can give them a system that's observable, it's going to give them insight that they've been craving. They're probably frustrated by having these black boxes to operate and having to dig around in logs they don't understand. And if you can have an observable system that can provide data and a shared language that you can both look at, both the applications engineering team and the operations team, well, that's going to help you work better together. Isn't that what DevOps is all about? Swear jar. Isn't that what this is all about? Helping you work better together. But also, why wouldn't you want to understand your system better? Like, even if you've decided to specialize in that way, that it's somebody else's responsibility to run in production, you're going to be able to do a better job if you understand how it works in production. Is implementing that new feature going to put strain on a resource that you didn't know was strained? Well, better if you knew. Because you don't understand a system until you've seen how it behaves in production. Anyway, enough preaching. How do we actually make systems that are observable? Well, I'm going to talk about a few tricks. And the big one I'm going to spend most of the time on is logging. But a couple of quick things you can do. Try putting some introspection endpoints into your app. So I'm assuming here your app is speaking HTTP. You can do similar things if your app speaks some other protocol. Try putting an endpoint in there called /status or something. Hide it behind a basic auth so that it's not web accessible. But wouldn't it be nice to be able to ask your app how it's doing? Are you OK? And it might be as simple as this. Even if this is all you do, if you curl the app and you get an OK, that's good. If you get a socket timeout or you get a 502 gateway error, well, that's useful to know as well. I mean, hopefully this isn't the only way you can find out. But if you're troubleshooting a situation where one of your instances is not responding, wouldn't it be nice to go check how many instances are up? And you can also take this further if your process needs to do some complicated startup procedure, like establishing a connection to a database or warming up a cache, then you could arrange it so that this status endpoint doesn't start saying OK until it's actually finished all that. And that can be really useful to find out if something is stuck or if all your processes are in that state. Similarly, wouldn't it be nice to be able to ask your instances what version of the software they're running? Has anyone tried to debug a thing where they thought they'd fixed that already, but they're not sure if the fix is quite rolled out to the instance that the user might be hitting? Or even better, it's rolled out to some of the nodes, but not all. Maybe your deploy process got stuck somewhere, and some poor user is seeing an intermittent error that's happening 3 times out of 4 because they're load balancing between instances. Again, it'd be really nice to just be able to check this. One more variation on this theme. You can have instances keep track of internal stats, maybe some details about how they're working, that cache that they're warming up. Well, it'd be useful to be able to ask how successful is your cache actually being in this process. So these are some nice tricks you can do, but we really have to talk about logging. Because a great way of making a system more observable is to have it write down everything it's doing. And logging is great, right? This is the ideal of what logging can do. We logged that we're processing a request, and then there was some kind of warning that we decided to carry on anyway, and then we hit an error. Oh no. So when we're looking back in the logs later to diagnose why the user got an error page, we can look here and we see, oh, well, there's a bug in adjust sprocket. We need to fix that bug. This is the theory. In practice, it can look more like this. There's sort of a rule of thumb that says don't put too much text on one slide. And I decided to break that rule because this is what logs normally look like. There is way too much information going on here. Like we're processing a whole bunch of things, and this warning appears a bunch of times, and sometimes there's an error after it, and sometimes there isn't. And we're also logging the fact that requests completed successfully, which I don't know if that's ever going to be useful to us, but it's in the log anyway, so we need to sort through it. And actually, this is probably optimistic. Your logs probably look more like this, which I'm really glad this actually fits on the slide. As like warnings about some function being deprecated, and this should never happen. And hands up if you've seen any logs that look like this. Yeah, it's a good number of pain faces I see. So then we say, okay, well, our logs are too noisy. We need to do something about this. Let's make sure that we're only logging actionable stuff. And now our logs look like this. Well, we started up, and then 6 hours later, something blew up, and we shut down. Great, actionable information. Except what happened in the intervening 6 hours? Did this service do any work? Did it just start up and then get stuck and slowly burn for a few hours and then eventually catch fire and explode? We don't know. So there's this dichotomy between logs in theory and logs in practice. In theory, you have all these grand principles like log every time the system does any work, or only log as error if it's actionable, or in production, we're only going to output warnings and errors. These principles are great, but in practice, it ends up being more like this. I was trying to find the error that happened to the user, but I couldn't find it because the log is full of 1 million copies of the same warning. Or, man, I wish we'd turned on debug logging before the process crashed. How about this one? We're going to spend a sprint doing log cleanup. That's high-quality use of human time. The outage happened because one of our nodes went down because the logs filled up the disk. That happened to anyone? Yep, a lot of hands. How about all of the nodes went down? Because they're all logging at about the same rate, and we didn't have log rotation set up properly, so yeah, we just like went totally down. So in practice, logs are a pain. And the fundamental thing going on here is there's a lot of logs. Like, logs at any kind of scale get really hard to manage. The problem is you're reading your logs. Why are you reading them? Stop reading your logs. It's a machine that's generating these logs. You wrote software in the first place so that you could do things faster than humans can. So a machine is generating this data. Why is it a human that's reading them? There are too many logs for you to read, and you're too slow. It's going to take you time to figure out that you even need to look at the logs. Then it's going to take you time to find the thing you care about, and then it's going to take you time to do anything about it. These are all things that machines can help us do faster. So here's a machine that reads logs. It's called grep. This is about the simplest machine that we could possibly imagine, and this is going to help us get to errors quicker in a normal log file. Okay, this is useful. You're probably using this already. But I think we can imagine more interesting machines. Here's a more interesting machine. Exception notification. So you're probably familiar with these already. It's a category of services. For example, Bugsnag is exception notification as delivered as software as a service. Another one is Sentry. Sentry is also available as an open source product, so you can host it yourself. I don't work for either of these companies. And the idea behind exception notification is every time you have an error in your application, you send it to the service, and it'll tell you if it was a new exception, and it'll keep track of all the exceptions that have happened, and so it can dedupe. So if the same thing happens again, it won't bother sending you a new notification. It'll just sort of track another instance. And it tends to look like sort of an inbox, like here are all the things that are broken in your app that you haven't fixed yet. And because these things know they're working with exceptions, they tend to have extra useful things like they understand what stack traces are, and they can link to your GitHub repo, or they understand things about your programming languages. They can, unroll source maps if you're using JavaScript. And these are really useful. These don't normally get talked about in the context of observability, but I think these are actually one of the most useful things you can do to get some visibility into what your app is doing. If you haven't tried using one of these things, you're probably used to just looking at like an error graph and the error spikes, and then you go dig in the logs for what happened. And when you start using an exception notification service, you have a couple of revelations. And one of them is, I got notified that something broke in my app before a user told me, or before my ops team told me. That's really cool. I can just go straight to the thing that was broken. And then the second revelation is, I just got notified of 500 other things. Wow, there's a lot of bugs in my app. Where is all this coming from? Because you don't understand your app until it's running in production. Exception notification services are awesome, but they don't solve all your problems. And the biggest problem area for these things is intermittent errors. Exception notification services tend to assume that most errors that happen in your app are bugs. They're your fault. You made a mistake, you wrote code that was wrong, or you forgot to anticipate some edge case, and that's why it broke. But some errors aren't your fault. Some you can't fix. Let's say you're calling a third-party service, payment service, or you're calling Google for authentication, and that timed out. Well, you can't fix that. I mean, you can try paying them more money, or like sue them or something, but like you can't fix that. At least not your engineers can't fix it. I mean, you can add a timeout, but we'll come back to that. And there are also errors that you won't fix, otherwise known as warnings. There are some errors you might just be fine with happening, like it happens in the background process, or it only happens to 1% of requests, or maybe 0.01%, and you hope it's not all the same user. And maybe you just decide we're OK with this. Or just you have finite effort, and you have to fix the most critical things first. But just because you aren't going to fix these doesn't mean you want to forget about them completely. You could always comment out the catch block. But you might want to know how often these things are happening, because they're telling you something really useful about your system. All those warnings that you put in your code and then never look at again are actually telling you that one of your assumptions was wrong. But you sort of want to know, I reordered this. You sort of want to know how often they're happening. These things are really hard to manage. You're never going to fix all of them, but you want to know, are they happening a lot? Or are they happening occasionally? Are they all happening to the same user? So relating this back to logs, telling an exception notification service that an error happened is actually pretty similar to logging that an error happened, right? The difference is that exception notification services are machines reading your logs instead of humans reading your logs. And so we're sending the data in a different format. We're structuring it for machine consumption. What does that look like? Well, it might look like this. You emit a thing. This is a log, basically, but it's a structured log. It has information about which hostname was reporting the issue, the error that occurred, stack trace with lots of entries and line numbers and stuff. And there could be way more in here. If you're sending logs for machines to read, then why not write logs that machines are good at reading? Like, machines can read those human-readable strings that you're outputting, but parsing strings is slow. Regexes are pretty slow, and it's really imprecise. Like, you've done all that work to output like nice, grammatical sentences that say this thing went wrong for this user, and you're like taking the user ID and putting that into a string. Well, the machine just has to pull that data back out, and you're going to have problems with delimiters, and I don't even want to think about it. So if you can output data in a structured format, which just means anything that can write JSON, then you're going to save the machine a lot of work. And now that you're structuring your logs, you can add lots more information. You're no longer trying to stuff things into this little string that's human readable, so you can add as many properties as you want. Add things that are interesting to the work that your app is doing. Put in the user ID. Put in what kind of mobile platform they're on, whether they're on a mobile platform. Put in the number of items that were in their shopping cart at the time when the bad thing happened. And once you have structured data, then you can analyze it. So you can ask questions of your logs, like which of our items that we sell has the worst cache hit rate? Or I know that some users have large shopping carts. Tell me the error rate for those. Maybe they're doing worse than others. Now we can do analysis. We can do something better with those warnings. We can look for trends. We can look for correlations. How often does that sprocket cache warning actually happen? How many users is it affecting? Does it happen at the same time? If we can look at a graph over time, does it happen at the same time as traffic spikes? If so, then that doesn't prove anything, right? Correlation doesn't imply you all know this, but it gives us a hint as to what we might look for. Also, if it doesn't happen at the same time as traffic spikes, that tells us something interesting. Does it only happen on certain hosts? Just tell me if it happens more often than it used to be happening. Maybe you're just saying, I don't care at all if this thing keeps happening at the current rate, but if it spikes, then that's really important for me to know. So how can you do this? I've sort of been very vague about, oh, now you have structured logs so you can analyze them. And that's partly because I work for a company that sells a solution to this problem, and I don't want this to come across as an advertisement. But the truth is, this is a fundamental thing you can do with a whole bunch of different tools. There are tools like Splunk and the Elk Stack. Loggly, recently acquired by SolarWinds, does this. Honeycomb, which I believe I've mentioned, does this. But also, throw your logs into Google BigQuery. It's really good at this kind of thing. You don't have to pay anyone you're probably not already paying. If you have an in-house data pipeline, send your logs in there. It's going to be great. I promise you'll discover things to do with them that you didn't think you could do. You can write a stream consumer. If you have a Hadoop system set up, you can dump them in there, run Impala. Like, log analysis is a thing that there are loads of ways to do this. So let's go back to log levels, because that was sort of where I started this rant about logs. What are we going to do now that we have structured logs? We could just add a field to the structured log that says level equals error. That feels a little unsatisfying. Now it's machines reading the logs. It's not humans. Can we do better than that? We have these like 4 or 5 log levels, and like 7 if you look at the syslog spec. These are very coarse-grained distinctions. Like, is it an error or is it a warning? And these are pretty loosely defined. Like, every team's going to have different definitions for like where the line should lie, and they probably change their mind after the next outage. I think we can do better than this. What we're trying to communicate with log levels is how interesting was the event, because not all events are equally interesting. A host went down. That's very interesting. I want to know about that straight away, maybe even in the middle of the night. a customer couldn't buy the product because the server threw an exception. That's very interesting. I maybe don't want to get paged about it, but I do want to fix it pretty quickly. This is the thing that exception notification services are great at. Don't page me every time, but tell me if a new thing happened. A call to the payment service timed out, but we retried, and then it succeeded. Well, is this a problem? I mean, it worked as designed. The customer was able to give us money. But again, I still want to know how often this is happening, and how long it took, and things like that. What about this? A customer bought a product successfully. That's not a problem. That's the opposite of a problem. But I still want to know how often it's happening, and maybe what kinds of products they're buying. So we want to annotate our logs with an idea of how interesting the log was. But we can do better than a log level. What about a number? Something like sample rate of 100. Why is this called a sample rate? Well, this means this log represents 100 other logs that were just like it. And when we have this log represents 100 events just like it. Now we can throw away the other 99. What we're saying is, this is not interesting enough to report it 100 times. But it's interesting enough to report once. And we don't want to pay for storage for 100 identical things. We don't want to pay either a machine or a human to read 100 identical things. And because it's a machine reading the logs and doing analysis on huge volumes of logs rather than a human reading page by page, we can get away with this. And this is a technique called dynamic sampling, because static sampling is when you just say, we're going to throw away 99% of all of our logs. And that's really problematic, because the most interesting things are usually the least frequent things. And so if you're sampling statically, you're probably going to drop the actual thing that you cared about. But dynamic sampling is saying, as you're about to emit the event, use the properties of the event to determine how interesting it is, and therefore to determine the sample rate for that event. And dynamic sampling requires tool support. You need your analysis tools to understand that events are tagged with this sample rate and how to change their calculations to do it. For example, if you're counting sampled events, you need to basically add up the sample rates. That gives you an accurate count of how many events happened in the system. If you're doing averages, then you do something similar, but with the denominator of the average. And there are other adaptations you can do for other calculations. But the tools need to know about this. If you're rolling your own analysis, if you're doing Kafka Streams job or BigQuery or Impala or something, you can build this into the logic that you write. There are some tools that understand this natively, and so you don't need to worry about that. Enough said. But dynamic sampling is a really useful trick, because basically this is a way around that volume problem. If the problem is we're emitting way more data than we can ever use, then why emit all of it? Let's emit statistically appropriate samples of that data that still let us ask the questions that we want to ask. So to recap, the problem with logs is there's too many of them. We need to write logs in a way that machines can analyze them, instead of writing them for humans to read. If you're not using an exception notification service, then totally try that. Stop reading your logs and start asking questions of them. And just a little bit more. There's this interesting notion, so there's this notion of observability, but there's another notion of controllability. And these things are both taken from the field of control theory. And so here's the sort of abstract definition, like a controllable system is when an external input can move the internal state of the system. And it turns out, mathematically speaking, this is actually the dual notion to observability. And so with apologies to any actual mathematicians, I'm just going to say this means that they go really well together. So here's a really simple example of what controllability might look like. Let's add another internal endpoint to our system that lets you set the log level dynamically. Now you can take the system that appears to be breaking, that was previously running on like log level warning, and set it back to info and hopefully get more information. Except I just went on a whole rant about how bad log levels are, so I need a better example, really. So let's look at feature flags. If you're not familiar with feature flags, this is basically about turning parts of your system on and off at runtime. Or maybe turning them on and off for certain users, or for 10% of your traffic. And basically how this works is you deploy both code paths, both the on path and the off path, and you check at runtime which one you're going to do, rather than just you're shipping a new feature, so you ship the feature and you get rid of the code that doesn't do it, you ship both of them. And this is really useful for all kinds of reasons. It's a great way of reducing risk and moving faster and testing stuff more quickly. There's probably been other talks about this. But I want to talk about how this is related to observability. It seems a bit unintuitive, right? This is about changing the behavior of the system. What's that got to do with understanding the behavior of the system? Well, for one thing, the system is not just the code you wrote. The system includes the humans that interact with it. So in a certain sense, you can't observe the system without modifying it. But beyond that, this means you can poke it and see how it responds. Like observing a system isn't just about sitting back and looking at it. It's seeing how it responds to stimuli. Because you don't understand the system until it's running in production. So we can test things in production. You can, if you're rolling out this feature, you can try rolling it out just for your team. And then you can observe that feature safely without breaking the rest of your users. And you can see how that feature behaves in production. If you rolled out a new feature and then a user said something broke, you didn't think it was going to break anything, but some user says it's broken, you don't know if it's that feature or not. Well, you can turn off that feature just for that user. You don't have to go roll back the whole thing and then worry about, oh, we reverted it, how long is it going to take before we can unrevert it? You can just flip it off for that user and see if it fixes it for them. And if it fixes it, then you know something about the code you rolled out. And if it doesn't, well, then bad luck. Similarly, you can ramp changes gradually. Ramp it to 10%. See if it's going to have an operational impact. Other techniques along these lines, you can do canary deploys, deploying only to certain hosts. This is great for changes where you need to run it for a while and see if it's going to do something horrible to your system metrics. You can do some of this sort of stuff at the load balancer level, which is really nice if you want to be able to route a user to a particular server, which you've put into an extra verbose logging mode, and then watch it while they do things. Or route a user to a version of the code that is specially hacked for them. Chaos engineering, I know there's been a lot of discussion about that, is sort of another way of doing this. It's basically saying, if you want to observe the system in production, you need to observe it in a variety of different situations. So, in conclusion, observable systems are systems that help us understand them. Because you don't understand it until you've seen it in production. You need to understand what normal looks like. And that means we can operate it better, and it helps us maintain it. Your logs are not human scale. They're machine scale, so you need to write logs that machines can read. Use things like structured logging, use dynamic sampling as a way of dealing with the cost of logging. And controllability, for example, feature flags, and observability are a great pair. When you can poke your system and see how it responds, that's another way of understanding how it works. And I'm happy to take some questions. I think I have a few minutes.
Thank you, first of all. When you say you aggregate the logs at some level, now you know that you don't need them, but there's a journey that leads to this, that you know that, okay, finally I don't need them. But then 5 months from now, oops, I want them back. Do you keep also the raw data, or?
So the question, if I understood it, was you're deciding to throw away these logs, but what happens when you find out later that you actually needed the logs you threw away? Yeah, so there's a couple of approaches to that. One is you can sort of decide whether to pre-sample or post-sample. So if you have some system where you're happy with the cost of keeping every single log, and another one which is more expensive, then yeah, you can store everything in the cheaper system, but sample for the more expensive system. Another one is to say that in a lot of cases, you can sort of get away with dropping individual copies of the data so long as you have. So an exception occurred, and it'd be really nice to see the exact exception that occurred. But if you have another exception that occurred with similar properties, maybe that's good enough. Unless you're in you might be in a regulatory environment where you literally have to be able to track down every single request. But sometimes it's less about, the exception's already occurred, like that request is lost forever. But if you can understand what was wrong with that request and requests like it, then you can fix it for the next time. Because the code is still deterministic, right? If it broke, it probably broke for a reason. There's probably something that can happen again. Yeah, that's a couple of answers to that.
What are your thoughts about using metrics tools like Influx or Graphite or things like that? And how does that compare to logging in your mind?
Metrics tools are fantastic. They are really good for understanding trends of things and spotting correlations. And if you've done enough work instrumenting, you can get a lot of insight that way. What they are less good at is asking arbitrary questions. So if you've had the experience of, you look at a graph and it has a spike, and you're like, oh, I wish I could understand why that spike happened. If only I could break that spike down by different users or by different mobile platforms or something. Logs are really good for the opposite, right? Logs are really good for looking at the individual details of a particular thing and seeing, the events that led up to that thing. I think to get observability, you really need a bit of both. Like, you need to be able to get the broad aggregate view, but you need to be able to see the details when you need it. Oh, I guess that another aspect of that question, there's the infamous high cardinality problem. Metrics tools have a problem with combinatorial explosion of dimensions. If you want to see that error graph broken down by mobile platform and endpoint in your app and geographical region and maybe even like user cohort, then just that one graph is now like 1,000 graphs, and you're doing that for 1,000 graphs. Now you have 1,000,000 graphs, and now no human can read them, and also your metrics tool is really expensive now. Which makes it, again, it's harder to ask questions of a system like that, where you sort of have to pre-plan in advance what kind of graphs you want to look at. But they are an essential piece of the puzzle.
Sometimes hard to define when things are running normal, because you can have a spike in traffic, let's say, which would, statistically speaking, perhaps increase the number of errors, but they're still normal. So are there any tools or any tips to provide some sort of adaptive, if we will, measurement to be able to trigger only when it goes above a certain pattern?
Yeah, so yeah, detecting what's not normal is kind of a lot harder than detecting what is normal. There are a lot of tools that will claim to do that automatically for you, that will use machine learning to distinguish between like a normal spike and an abnormal spike. If I meet someone who's using one of those and happy with it, I'll let you know. Sorry that I probably just offended like 15 people in the room. There's probably a lot you can do there, and there are some statistical techniques you can do, analyses of time series and that sort of thing. But I think that even if you have one of those tools, there's still a human activity you need to do, which is learn intuitively what normal is. And if you have that, then yeah, I mean, everyone's had the experience of the sort of magical ops person who can just look at the dashboard and point at one graph and be like, that's the problem. And you're like, but the other one spiked too, and yeah, but that's normal, that one isn't. You only get that with intuition, and it doesn't matter how many auto-detection tools you have, you still need that, because they're going to produce false positives or false negatives. You always need the human. So I think that it's really important to invest as much as possible into making that easy to learn. And anything else is sort of valuable and probably can save us effort.
I'm kind of on the same path where I'm looking to start doing quite a bit more logging, and some of the advice that I've been given so far is do not invent your own logging format. I've heard that time and time again, and because there's so many that exist already, and they already have, you know, plugins for this, that, and other visualization tools are compatible with it and whatnot. I wonder if you had any comment on that.
If I understood the question correctly, you're saying you don't want to, there is advice not to invent your own logging format because there's lots of tools available to deal with them. And there are some efforts to produce some standardization. Honestly, everything I've seen so far works really well with JSON. So it's sort of a standard, at least at the wire format level. There are extra details you might want on top of that, like, you know, is there a standard for what a sample rate should look like? Maybe it would be nice that there is a standard for that. And is there a standard for what the hostname field should be called? Is it host or hostname or server or that sort of thing? I know there's a project that Google is spearheading called Open Census, which is sort of trying to be a bit more general than just logging, but I think it would probably encompass that. Open Census can do with distributed tracing. There's also, so Open Census is trying to standardize a wire format and some libraries. There's Open Tracing, which is trying to standardize some semantics, but not a wire format, which is a different design choice. Yeah, but if I was you, I would start with JSON and see how far I can get from there and worry about further standardization later.
Yeah, the JSON payload for us work excellent. Everything goes into Kafka, Elasticsearch, Hadoop, and then you can do Grafana to do graphs based on n number of fields, right? You have in the payload, so it works for us. Yeah.
Oh, for the sake of your network bill, I should add gzip your JSON.
I think last question.
Okay.
From your experience, what is the effective way to do pre-sampling? Is it at the service level where you decide or remember how many, like 99 times have happened, so this is 100 times, do I need to log in then? Or at the Kafka stream level, or at the outside tool that basically getting all your loggings, and then at that point it decides to actually log it based on the sampling rate?
The best answer depends a little bit on your architecture. If you have tons of services logging into a single data pipeline, then you're more in the second scenario you described. But in general, the pattern we found quite useful for deciding when to pre-sample. You define a bunch of properties of your events that you're going to sample on. So you might sample based on the user ID, and the path in the application they were hitting, and the status code. You know, you think that 200s are probably less interesting, and 500s are probably more interesting. And then you count, so you figure out in process the permutations of those variables. You count how many things you've got in each bucket, and then that's the sample rate, basically. So if you're going to end up with lots of 200s on lots of paths across all your user IDs, but you're not going to have as many 500s, so they get a much smaller sample rate. Right, yeah. If what you're doing is aggregating lots of logs from lots of services into a single pipeline, then you may need to do something instead, like not pre-sample, but you can still, you end up with sort of doing the same thing twice. Like you can pre-sample but attach the sample rate and then send it into your data pipeline, which might do another level of pre-sampling before it sends them off for analysis or something. We've seen customers doing that.
Thank you very much, Sam. That was very informational.